Now, our next talk is about sustainability, and the speaker is Professor John Byrne, or AKA JB, who is the director of the Center for Energy and Environmental Policy here at the University of Delaware, where he's also a distinguished professor of energy and climate policy. He's contributed to the working group 3 of the United Nations-sponsored Intergovernmental Panel on Climate Change since 1992, and shares the 2007 Nobel Peace Prize with the panel's authors and review editors. He's chairman of the board of the Foundation for Renewable Energy and Environment, an international organization established to promote a better future based on energy, water, and materials conservation, renewable energy use, environmental resilience, and sustainable livelihoods. JB, it's a pleasure.
Thank you, fella. Thank you very much. I really appreciate the invitation, Mike, and thank you for all the work that UDEI does for our campus. I don't want to lose this, so I'm going to put that there. So, and it's great to be here again with Christiana. We've been interacting virtually for quite some time, but it's been physically several years since we've, so it's really great to have, I think, one of this country's best PV device designers here back on campus. And okay, so mine is going to be a little bit different. I am going to try and talk about how technology, economics, and policy can link to address the Terawatt challenge. And so I'm going to try and walk you through what that looks like. I'm going to begin, because that's my job often, I'm going to begin with the climate question and then use that as a way to begin talking about this integration that's needed. I loved Chris's last slide. My team is working with, we're very privileged to be working with the Quest effort. We're not allowed in the laboratories for good reasons that we could cause severe problems if we were in there. And, but when something comes out of the labs that might be useful, the questions of how to take a technology and move it through an economic system and how to get policy behind it and how to get society after it, you know, Terawatt is not a small challenge. So if you want to do that, you're going to need to have those kinds of integrations, and that's our role. So let me begin with the first slide. In case you didn't notice, human activity has changed the chemistry of the atmosphere, and there are a series of impacts that we are experiencing that are associated with that change. We have moved greenhouse gases, particularly carbon dioxide, from pre-industrial levels to quite handsomely large. We actually hit this past year 400 parts per million. So this is the published work of the IPCC on this, and there will be more reports coming out in about a month. So I'm not using those until they are released from embargo. So we have put this, we have changed the chemistry in the atmosphere. We've put a lot of chemicals up there, and we now have the dilemma of a series of impacts that come with them. And I'm not going to give you detailed definition of all of those changes. I'm simply going to remind you of weather events that are somewhat interesting for us living in the times after we made this chemical change. And I'm going to, yes, given what's been happening here on the East Coast, I'm going to torment you with snow and ice and freezing cold weather pictures. So let me start with in the Antarctic. This is an ice shelf, part of the Larsen Shelf, that you have a picture at the end of January in 2002. 3 weeks later, that shelf had begun to fall apart, and in 2 more weeks, a total of 5 weeks, since you are in Delaware, an ice melt on the scale of the state of Delaware had taken place. And I just want you to keep your eye on, there's one piece of this particular ice melt, B17B iceberg, which was broken off, and well, it went sailing, and the iceberg is about the size of Manhattan, and it sailed for about close to 9 years. And in late 2008 and early 2009, there were interesting stories in the newspapers in Australia as this mass made its way toward the western part of Australia. It was never actually going to collide because the warm waters that surround the continent made it so that the B-17B is no longer a threat to any of us. It's now broken up into several hundred pieces, and but it's still sailing around. And so we had an interesting event in the Antarctic, which is not one that we were able to explain in the past, and caused a lot of consternation in the IPCC, and actually started a special working group on how ice melts. We thought we knew, and there were a lot of things that were learned from this particular event. Up north, well, if you're in Australia, they don't believe it's north, but anyway, in the Arctic, about 40% by volume of sea ice has now melted. The Arctic is actually the fastest warming part of the surface of the Earth in the last 50 years. And an event took place there also that we were kind of not prepared for. This is a satellite measurement of ice melt on, surface melt on Greenland. And on the first day of July, about little over 40% of the mass was experiencing some level of melt, which is not inconsistent with what happens during this period of the year. What happened 12 days later was not something that was consistent. We went from about 40% or so subject to surface melt to over 95% surface melt. And this has stimulated for many in the IPCC a new round of trying to understand what is happening, particularly in the coldest parts of the planet as a result of our storage of greenhouse gases in the atmosphere. So this was sort of one part of our planet, another part of our planet. Let me now take you to today. The circumpolar vortex, which seems to be all over the news these days, and certainly is gracing the mid-Atlantic with interesting temperatures once again, which led to outside the laboratories, discussions of these sorts of ideas can mean that an event of this kind will suddenly, particularly in talk radio in the US, lead to the conclusion that there is no climate change or warming, which you would wonder what happened to us that we have an entire public communication sector that can make mistakes like that. But anyway, it required, as a result, none other than John Holdren, the president's science advisor, to try and explain why it is that what's been happening over the last 2 months in different parts of the United States is actually consistent with the thesis of climate change. And so there is if you haven't seen it, there is, I think, in terms of a public communication event, there's a 2-minute video that has been put up by the White House that tries to offer some ideas on why that is. Essentially that the warming in the Arctic has led to a disturbance of the circulation pattern, what John calls in the short video waviness, which you can see in this particular case, which is pulling down Arctic air and letting it settle in lower latitudes for periods of time. And I don't think we're out of it. We still have a few more weeks of this to go, at least 1.5 weeks or so to go in this, and it's been an interesting time. So this kind of variation is a variation that was both not easy to explain with past modeling, and not because it didn't conform with an underlying thesis about climate change, but because these particular events are triggers of activity that are beyond what models had heretofore expected. So that's the end of the torture with the cold bits, and let me now take you to where, when we melt water, when we melt ice and when we warm water on a planetary scale, we also affect other parts of the planet, and I'm going to spend a little bit of time on Bangladesh, which is located in the Bay of Bengal, one of the areas most vulnerable to storm surge. So those activities of change and variation have led to, for this region of the world, repeated 5-meter storm surges that have been taking place now for some time. These darker blue areas are the areas where populations must evacuate whenever a 5-meter storm rolls in. And the estimate is that about 3% of the population currently is at risk because of these surges. But we are projecting that we're going to be dealing with something closer to 7-meter storm surges, and that would indicate these dark blue areas would then go underwater, and would lead to a population of refugees of about 10%, about 23 million people. What's a 7-meter storm surge for folks who have lived in this area? So the Haiyan cyclone that banged into the central Philippines the end of last year is a 5-meter storm. Katrina, which banged into New Orleans in the United States, is a 7-meter storm. And Sandy was at more than 9 meters as a storm surge. So these sorts of irregularities, at least by what were past weather patterns and part of an earlier climate with a different chemistry, are what are now worrying folks about the kinds of experiments that we're now conducting in the atmosphere. So I'm going to now turn to the question of what's propelling this change, and what is propelling this change is essentially an energy sector that is vital to an economic model that has actually worked in the last century and some years, and I'm going to try and demonstrate that success, but also the implication that we now face and why the Terawatt challenge is so crucial to our future. So to do that, I'm going to give you a simple way to understand rapid economic change. This is the city of New York, and it is the same intersection, Times Square, in the city of New York from the end of the 19th century to the beginning of the 21st century. So this rotation in 100 years is the build out of an economic model that was able to provide prosperity to New York City residents in a way that was unimaginable at the beginning, 100 years earlier, and now represents one of the iconic symbols of prosperity and growth that is to be imitated. This model took 100 years to put about 6 million people in that prosperity zone. This has been, as a model, exported. This is Beijing in 1949 and in Chang'an Street, and we're going to roll down Chang'an Street today, which looks like this. You've got roughly in Beijing, roughly twice the New York population in roughly half the period of time, 50 years, a level of prosperity created in the world. And that boom that has happened in Beijing is again one that is celebrated. It is the fastest growing economy in the world. But lest you think that, if you will, the Moore's law of economic development or an equivalent has finished its work, you might want to look at this particular city, which several of you should know in this audience, Shenzhen, across from Hong Kong in China. This is Shenzhen in 1980. It is a several hundred thousand resident city, mainly built around its fishing industry. Get ready. This is Shenzhen today. 25 years later, it now has roughly 11 million people. So you have cut in half, again, from the Beijing case to the Shenzhen case, a condition of prosperity that's taken half the time, again, to produce against what it was before. And this, of course, is also a city that produces a lot of PV modules. So you should know this, this particular place. This is part of that manufacturing economy that it almost certainly is going to give us hope. The challenge, of course, is that if we develop this way, and you can see from this NASA stitched together expression of how widespread this particular model has become across the planet. This is light-sensitive photography, and this is an indication of the concentration of light at night for the same hour of the same day on the planet, and an indication of just how fast we are spreading this model around the world. There's plenty of more room to go, and it will happen. But if we do it the way that we are now doing it, the kind of variation and difficulty in trying to just make daily life work is going to exacerbate in our very near term future. So what is the alternative? We have known this alternative for some time. This is an IPCC synthesis of what are the options for us to get out of this particular situation. It is not to change that prosperity cycle necessarily. It is instead to change the underlying energy requirements of that prosperity. And the analyses that have been done by the IPCC suggest that there is a great room for us to go and find and implement a sustainability agenda. The agenda is to take out about 23.7 gigatons of carbon dioxide and its equivalent out of the human activity, and the chunk of that, about 80% or so, 85%, is going to come from the energy sector, and in that about a third is going to come from the electricity sector. So if you were to divvy up that wedge and assign it to who's going to do what, about a third of it needs to come from the electricity sector, and if we were trying to use the clean energy that we need from the electricity sector, if we were to try to do it in solar, we're going to need something in the vicinity to get this reduction by 2030 to keep us on track for where we need to be by mid-century. We're going to need something on the order of 8 terawatts for this wedge component, not for all of what can happen, just for the wedge component. So a terawatt challenge is an important challenge. I don't think it is an overly, it's an overstated challenge. If anything, we probably need to even begin at some point to think about a challenge that's even more aggressive than a terawatt. The good news, as Chris pointed out, is that we do have a sense that we can begin to achieve this rapid growth that we're going to have. We, on the one hand, have urban prosperity moving along at clips that are just unbelievable. I think even for Americans today, to see something like Shenzhen to happen in 25 years, I think it is, most New Yorkers themselves can't imagine that something could move that quickly. The good news is that the photovoltaics and other clean energy technologies are growing very rapidly. In fact, photovoltaics is, compared on its own performance year on year, is able to double in roughly 2 years. The reason for that, this used to be an old, Chris had a picture in there of levelized cost of energy. This was something that folks like my center did for a long period of time. You can tell the difference in how the dialogue is going on this when you consider this diagram is actually not written by nerds in universities. This is Lazard Investment Bank advising its investors of where to put their money in the energy sector. And the advice is that parity is already here in some cases and coming somewhere in the vicinity of 2015, 2016, and this is with subsidies. So these continuous lines for thin film and for crystalline are with the subsidies that are in place. I want to briefly indicate in this efforts to compare solar against Another resource without considering subsidies is foolhardy. There is no energy source in not only the US but in the world that isn't subsidized. So if you're going to do a fair comparison, you either put everybody's subsidies in or you take everybody's subsidies out. You can't leave in the subsidies of one industry that's had 100 years to enjoy privilege and then say to renewables, oh, by the way, you need to compete against the prices that have now been set by that set of subsidies over the last 100 years. So go one way or the other, but don't mix because they don't match. Okay, so we have the opportunity, particularly with solar technology and its rapid growth, the rapid improvements in the technology itself, which Crest represents. It's improving economics, which enables us to maybe catch up to the speed at which urban prosperity is occurring. This is the challenge. I mean, there's one kind of thing of looking at against the US energy system, and I'm not knocking that we shouldn't be trying to find a way to dig into the US energy system, but our world is rapidly changing in other places compared to the US. The US is currently the turtle. It is not the hare in the race now. We change much more slowly. The world is changing much more rapidly, and we have to find a way to build an opportunity, a terawatt opportunity that can keep up with and hopefully exceed the speed that's happening elsewhere. So how do we do that? I want to give you an example of a particular space that we just worked on in the last 40 years on a terawatt kind of discourse. This is the city of Seoul in South Korea in June 1950, 1 month before civil war breaks out on the peninsula. This is the city just a few months later as war devastates the city, basically levelized the city, and it has to be rebuilt. That's Seoul today. It's now 12 million plus people living in, again, a kind of zone of prosperity that those earlier graphs indicated. And the speed at which this kind of thing is happening is quite stunning, but it is the speed that we have to deal with in order, if we're going to actually make the changes that will be meaningful in the future, we have to measure them against places like this. So what do we do to try and catch up and exceed those paces of change that are in the economy? There's a very important resource on display in this particular image, aerial image of the city of Seoul. It is its rooftop real estate. There is an immense amount of rooftop real estate available in this city that is already collecting solar energy. It's just not fruitfully being put to use by the city's businesses and residents. So we've been doing this for a long time now, these kinds of calculations, to try and figure out what is solar potential in various different formats. I'm just doing the rooftop here. There are a series of other ways in which you can think about this. But basically, what it involves is taking what is your rooftop area, utilizing some features that make the particular rooftops themselves maybe not usable for this particular activity. Most of the rooftop real estate in these large cities is flat. It's not necessary, but there is some shading because of taller versus smaller buildings. There are such things as heliports for evacuation and so on. If you take these out, and if you look at what kind of tilt angle you're going to use for the power system you're going to put on top, and some service area that's going to be needed in order to make the system actually maintainable, with conservative estimation, we end up with only about, out of that original 180 plus million square meters, we end up with only about 30% or so of that real estate. Now, we did this purposely on a conservative basis, but with that, you get a result that's something like this. If you look at, if you compare that potential against the city's own use of electricity, you're looking at a production at 20% module efficiencies. You're looking at something on the order of 30% of the annual electricity use of a big, rapidly growing city like this that can come from the conversion of its rooftop real estate to usable, active solar electric systems. Its capacity, solar installed capacity is something on the order of 11 gigawatts, which is about half of the peak that happens in this city. So this is transformative. It is possible to move very rapidly in these kinds of cases. This kind of transformation is, I think, the sort of scale that we're going to have to deal with. So can this kind of thing happen? The next step, you need a couple of things. Now we have technology, but you need some economics and policy to make it work. So we have been working with the City of Seoul to develop a pilot for both measuring and validating this kind of model of change. And we have come up with a financing approach which is similar in form to what Chris mentioned, in which you don't actually own the system. You simply buy the power from the system. Because Korea subsidizes electricity a great deal, including its nuclear plants, you have to beat a hurdle rate of 8 cents a kilowatt hour. So we worked on a model, a financing model that would make this happen. This is built off of a model that we built here, created here, called the Sustainable Energy Utility, in which we utilize efficiency improvements and the net surpluses that efficiency improvements give in order to buy down the capital cost of solar, and then in this way make it workable for. We took a small area, that's what we have proposed, 1% of the city's roof area, which will give us something on the order of 511 gigawatt hours. Now, can this such a thing actually work? Well, again, the policy world is in a stage of ferment. There is not a lot of evidence at the, well, there's really no evidence at the national level in the US of this kind of improvement. At the local level, there is a great deal, but if you will go outside the US proper, you are going to see changes that are eye-popping. The city of Seoul has a mayor who is now running on a obligation for the city to cut its electricity use by 1 nuclear power plant by 2015. The reason that the nuclear power plant has become important is that there was this little itty-bitty device that was in each power plant there about 10,000 times over. It was a little switch. And they found out that the switch was made not by a certified vendor, and every switch has to be taken out. So the City of Seoul has now seen significant reductions in its summer capacity, and as a result, this situation has become very important for the city to think about its future. This has led to a proposal. This is real. This is not, I mean, in policy terms, this is really what's being attempted to replace about 5 gigawatts of power with a combination of energy efficiency and a pilot for solar that, again, would provide the basis for the city to learn how to make these kinds of changes in a rapidly developing area. Okay, so let me close with, can any of this finally be realized? Is it something that really can happen? Let me first just stay in Korea with a final picture on this prosperity theme. This is the district of Songdo in the city of Incheon, which is if you fly to Korea, you fly in, the international airport is in Incheon. Songdo was essentially a warehouse and port services area that had no particular population and no particular description that merited any consequence for an international audience to consider. But between 2001 and 2012, Songdo built a new city, 170,000 people, so that's half the speed, that's half time again of what Shenzhen did, okay? It has the largest pipeline of LEED certified building real estate in the world. This happened in a couple of years to build out this kind of scale. And it is now becoming a city-in-a-box model that is being looked at in various parts of Asia as a way to take this kind of opportunity out and try and catch up with the speed at which change is taking place in our world. I can't say that the evidence is in that we know on the economics and policy side how to effectively produce a change that is as rapid as the change that is occurring in these parts of the world. But I can say that if we don't make the effort to link technology, economics, and policy in this fashion, we're almost certainly going to find ourselves with continued interesting experiences. No one knows next what the next variation and whether will be that we will say, we didn't explain that one either, but we're likely to keep taking risks of that kind. So. Can we get to a terawatt economy? I sure hope so. I think there are reasons for us to have hope, but we are in a race, and that race is one that is going to require us to go actually much faster than we ever have before. And that's my comments.
Brief 3 or 4 minutes for questions for JB?
Yes, Steve.
Okay, so you mentioned comparing technologies either with or without incentive. There's been a lot of different incentives applied around the world for photovoltaics, solar renewable energy credits, the wind tariff, outright subsidy per watt installed. In your view, I could imagine different ones would apply at different stages and in different countries. In your view, what would be some of the best incentive approaches to encourage PV? Is it a carbon tax or what?
So I think the ones that have worked are ones that tell a bank when a solar developer comes in and says, I have a project, that the bank says there's enough security in this project to merit the loan. If investors won't put the money in the project, the likelihood that we're going to actually succeed in any kind of scale like this is very small, because investors are putting money into, obviously these examples that I gave you of prosperity grow like this because investment flocks to these approaches. So the only way we're going to succeed is if we create that kind of security behind the investment. The German model of saying that up front you have a 20-year revenue stream that comes if you build, and that revenue stream is at this price. Everybody can predict it. Banks love that. They're ready to, and that's the reason why Germany, in a relatively low solar radiation area, is actually the host of the largest solar power plant in the world. So I think that's very important. There are other ways. The German model requires you to have a set of features of your utility sector and a political system that actually looks like now, as you know, Germany has had difficulty maintaining that commitment in the last 5 years. The US has a different approach where you don't ask politicians to vote for higher electricity prices. You instead simply say you have to go collect in a market the allowance rights to pollute, and then alternatively that you can utilize solar as a way to offset that kind of cost. And it depends, but if you do it and you do it right, it works. In the state of Delaware, there is an example just on how difficult it is. I don't know if you are aware, but Delaware is actually in the top 10 of installed capacity per person in the country. We are ahead of a bunch of states that you would think about. New Jersey, Delaware, and others are there, and the reason: we have higher prices for electricity, but we also built in a model in which an entity called the Sustainable Energy Utility buys 20 years of these renewable energy credits, and in this way gives banks assurance that there will be a revenue stream for this particular investment. I think that's the way it's always been. Railroads weren't built by folks saying, gee, I'll just take a chance, and I don't know if anybody will ever. That's not the way it's ever worked in any infrastructure that's ever been invested in, and if we want to make a sustainable energy as an infrastructure investment, we've got to find a way to. Is that responsive, or you want to ask more?
The carbon tax is something that a lot of people talk about, and as an indirect way of encouraging
Yes.
CO2 producing technologies. Is that something that you think is bankable?
Carbon tax, yes, carbon tax is a way to get at it, but exactly what you mentioned, it's indirect, okay? It doesn't actually send the funds into a capital project that would build a solar plant. It sends instead a set of signals into a national and international economy that says you got to adjust prices, okay? So if I could have, I'd certainly like to see us move in that direction, some fashion of pricing carbon and the adverse impacts that it's creating for us. Ask what the cost of the Sandy storm was to us. So we ought to have a way to do that. But on the other hand, I would really like to see us use some of the other tools that tell banks today that you can make the investment and it'll work.
One more quick question from Bob.
Yeah, hi.
Can you comment a little bit? There's only a certain level that you can go to with photovoltaic or other interruptible power sources without storage. What's the number that you work with? In other words, you have to have large capacity storage before a lot of these renewables come into play.
Yeah. So, I mean, if you're, obviously scale does matter. If you're dealing with different load types, load profiles in buildings and so on, you can get, but we typically think that we're somewhere in the 20%, 15%, okay, range, yeah, until we get a breakthrough on the storage side, okay? The only thing I would say is that that's without considering targeted efficiency, which would allow you to, again, increase that percentage, not by necessarily putting more solar in, but by simply dialing down inefficiency and building performance. Yeah, why are we, it's ridiculous.
So let's thank JB again, and we can continue this discussion. So now we'll turn to the DOE Sunshine Initiative. Our next